In organic chemistry, you will have to draw structures, right? You will have to draw your alkenes, your alkenes, and the other classes of compounds, alkynes, etc. In order to be able to draw these structures, you need to be able to draw Lewis dot structures. In order to be able to do that, let's discuss the important things that are needed for you to know how to draw a Lewis dot structure. We have to discuss the valence electrons. We have talked about the octet rule. Once you have these down pat, then you should be able to draw Lewis dot structures for any molecule, right? Valence electrons is very simple, right? And valence electrons is also known as your outer shell electrons, right? They're the electrons in the outermost shell. It's easy to identify the number of valence electrons in any atom. Your group number is equal to the number of valence electrons. It's really that simple. So let's take a look at the periodic table. Let's look at carbon, for example. Carbon is in group 4, which means that carbon has four valence electrons. Right? Group 4, 4 valence electrons. And we got 4. If you look here, you have hydrogen is in group 1, 1A, 2A, 3A, 4A. So carbon is in 4A. You ignore the 14, 15. That's not your group numbers. Always remember that on your periodic table, those bigger numbers on top, that's not your group number. So carbon is in group 4, which means that the number of valence electrons that we have is 4 electrons. So if you're to write the Lewis dot structure for the carbon atom, right, it would be this. If you were to write the Lewis dot structure for oxygen, let's find oxygen over here. Oxygen is in group 6, which means it has 6 valence electron. So notice I put one electron on each corner first before I started to double up. So that's valence electrons, pretty simple. Something to remember about valence electrons, they are the electrons that are involved in bonding, right? So your valence electrons are the electrons involved when a molecule forms a bond, when an atom forms a bond, sorry. So they're the only electrons that are involved in bonding. Let's talk about the octet rule. The octet rule, the oct should clue you in, right? It's about 8 electrons in the valence shell, right? So your atoms that are in group 1A to 7A, right? So here, 1A all the way through to 7A, right? When they form bonds, their goal is to achieve 8 electrons in the valence shell. This is important because when the atoms in these groups make a bond, they want to achieve the electronic configuration of the noble gas closest to it. So for example, when fluorine makes a bond, right, it wants to achieve the electronic configuration of neon. That's how you get that full outer shell, right? Now the whole goal for the full outer shell is because full outer shell with those 8 electrons in valence shell equal a stable molecule. So it has extra stability. So let's look at an example here. So let's call the carbon atom by itself. That's carbon, the atom, with its 4 valence electrons, right? But look what happens when carbon makes when carbon is in a molecule, for example, methane, right? You now have carbon, but it's now bonded to four. It now has four hydrogens bonded to it. So this is what happened in the molecule, and this is how carbon gets its full octet. Each one of those hydrogens have one electron that it will bring into bond with that valence electron of carbon. These two electrons make a single bond, single covalent bond, single covalent bond, single covalent bond. So if you look now, you'll see that carbon now has a full octet. It has 2, 4, 6, 8 electrons now that it has made a bond with the hydrogens. By itself, remember, by itself, it was just sitting there with its 4 valence electrons, right? But remember, the goal when a molecule bonds, for example, in CH4, this is a molecule. Carbon is making bonds with the hydrogen. The goal is to have a full octet, right? The goal is for carbon to have 8 electrons in its valence shell. So now it has 2, 4, 6, 8 electrons in its valence shell. And hydrogen, remember, hydrogen is our exception. A full octet for hydrogen is the exception to the octet rule, is when it has 2 electrons. So oxygen is also good. So in order to write your Lewis dot structures, right, it is important to understand valence shell and the octet rule.